Okay, we're now going to look at our final application with the um, financial matters concerning our log and exponent rules. Okay, so we're going to look at the mortgage equation. So a mortgage, of course, is just a loan. So this equation is going to work for any kind of loan, car loan, uh, mortgage. 5-year loan, 10-year loan, mortgage should be 20, 30 years, 15 years maybe. Okay, so here's the problem at hand. Okay, um, you want to buy a house, all right? No one has that kind of cash to put down $250,000 for the house, so you're going to apply for a mortgage, and typically you're going to take that for a 30-year period. So you're saying, okay, well, what are going to be my monthly payments? Well, of course, that's going to be dependent upon what your mortgage rates are. But here's how we work it out. Okay, quite simple. Okay, you go to the bank. The bank says, okay, you say to the bank, I want to borrow $250,000. Bank says, well, fine. Well, I have the money. I can invest it. Okay, and I can make a bunch of interest on it. Okay, so therefore, I should charge you what I would get if I were investing this and earning interest. And that's exactly how it's set up. And you look at the two equations. Here's the compound interest formula, okay? Right here. All right. Here's the annuity program formula right over here, okay? So here's your annuity. What you're doing is you are investing, as we saw before, this amount C every month, okay? At some rate, okay, for some period of time, and what you get is what you call the future value. Well, the bank that's essentially as if you were putting that money, that monthly payment aside to make that to pay for this. But here's the $250,000 over here being borrowed, okay? And the bank says, here's my 250, and I could be investing it and earning that much. So here's what you have. You have essentially, okay, you set the two equations, the compound interest formula equal to the annuity future value formula. And what we're going to be most concerned about here is, okay, find how much you put away a month, okay? So C is the monthly payment, P is the principal borrowed. For our case, here's the $250,000 is what you're borrowing. C is what we're trying to determine. G is 30 years, and the rate is whatever the current rate might be. Okay, so quite frankly, the equation is manageable, but it's a little more manageable if we simply solve this for P. Because what you're going to see in moving from this first line downward is this. Okay. Um, I'm going to, rather than solve for C, I'm going to solve for P. And because I'll just divide this expression 1 plus I to the power 12t on the both sides. And what I'm going to do to try to facilitate that a little easier, I'm going to pull this I out in front here, which is completely algebraically legal. All right, so I did that. I pulled the I out in front. I divide by this term right here. Here it is in this first line. Now, that fraction, okay, both numerator terms are on top of that, okay, which means we get a nice cancellation here. All right, now, so here you go. Just put both numerator terms over top right here. That's the same, that's 1. This is 1 over that, which means we can rewrite that as 1 plus I to the negative 12t power. So here's the equation. This is what is known as the present value equation. Okay, this is the present value equation. This formula up here for the annuity is what you call a future value equation. Okay, so the present value equation says, okay, here it is. Now, you could easily, once you put everything in, you can solve for for C. So you this is known as the mortgage formula. Okay. P is the amount you're borrowing. C is going to be your monthly payment. I is up here is going to be your rate divided by 12, and T, of course, is your time. So we're proceeding with this, and we're going to answer this question. Okay. I want to know. Okay. For a loan that I'm taking, a 30-year loan at 6%, on a $250,000 loan, what is going to be my monthly payment? So I'm just going up here. I'm putting everything in. 250,000 is the amount I'm borrowing. Now in this case, your rate is guaranteed. You will be paying that 6% for 30 years, unless you refinance because there's lower rates available. So, but that's what it comes up to. Okay, so you are locked in at that rate. So here it is. Okay, putting everything in. Again, the only thing we're wanting to find is the value of C. Everything else crunches in quite nicely. Cross multiply, divide by the 0.05. Okay. Get this value, 1 minus that's this 1.005 to the power negative 360. Remember, don't lose track of any of those decimal places. I mean, that could be create a significant amount in terms of dollars and cents. Okay. When it's all said and done, what we end up seeing is that we have a monthly payment of just less than $1,500 a month. That's $1,500 a month, okay? And for 360 months, all right? And on a $250,000 loan. So that's what you end up, that's your monthly payment. Now you might want to just perchance say, well, let's see, how much is that actually costing me? So we're gonna do it right out here, right, without any problem. Okay, on a calculator. So here you go. You're paying $1,498, $1,498. I believe this cents. Don't worry about that. Times the 360. That's 360 monthly payments. Okay. Is okay 539,000, okay, less the 250,000 that you are borrowing, okay, which is to say that you're paying more in interest. You're paying $289,280 in interest. Okay, so that's it for our video talking about mortgages. And we will run you through another video to look at the calculator program for this. Okay, but hopefully you can follow that and do the example problems I'll provide for you in class. Okay.